Hello again, everyone, and welcome back to Programming in Access 2013. My name is Steve Bishop, and today we're going to be continuing our discussion on VBA, Visual Basic for Applications. Today we're going to be talking about variables. Now, variables hold a place in memory to store your data. Unlike when we were storing data in tables on Access, when you're holding data in a variable, that's only going to the memory of your computer. And because of that, the value in your variable is only going to be accessible while the application is open, and it's only going to be available to the application. Unlike when we were storing data in a table earlier, that information, since it's being stored in a table, is going to be stored on your hard drive. And when it's when it's on your hard drive, essentially other applications will be able to access that information if they are compatible with Access. Now, the data type is going to determine how much memory is going to be allocated for your data. So when you're declaring your variable, you're also going to be declaring the data type that variable is going to be. And by doing so, you're going to tell the computer, you're going to tell Access exactly how much memory needs to be allocated for that variable. Don't worry, that happens automatically when you tell it what data type you're going to be using. By using variables, you're going to be giving that memory, that space in your memory, a name. It's going to make it very convenient. You're basically going to create a container in your memory of your computer that you're going to store the data, and then you just have to refer to it by name in order to go retrieve that data. This makes it easy to assign and recall the values of your, that you're going to want in your application. So you can easily assign and then recall a value by using its name rather than trying to continuously remember what the number is going to be, especially since we don't always know what the numbers are. Now, values can be changed and recalled repeatedly. So, in other words, you can assign a value like 2 to a variable, and then later on you can say, no, I want to change it to 4. And maybe you have different purposes of doing that. You may very well want to do that in your code. So you can change the value that's in your variable multiple times, and as many times as you want. And you can also recall that information that's currently in the variable at any time. And you could do it as many times as you want. You can even stick your computer in an infinite loop that just assigns and asks over and over again. So let's just think of, say for example that you had the globe. It's just an object. It's just something. It could be any kind of data. It can be a date, can be a time, can be an age, could be like I said, a birthday, or a currency. Could be the how much money you've got in your pocket. It can be anything. It can be just about any particular type of data that you want. What you're going to do is you're going to take that data and you're going to stick it in a container, and you're going to name that container. And in this case, we've called it var globe. Okay, so just so that I can easily identify that this is a variable that is going to contain globe as as the data that I'm expecting it to be. So what I end up with is the globe sitting inside of a box named var globe. Okay, so it's just kind of a good illustration, a good way to think. You've got a value here on the left that is the globe. You're going to stick it into a container, and that way you have the container holding your globe, holding your data. So when you're declaring a variable, you're going to need to use the dim keyword. And the dim keyword tells Access that you are declaring a variable. It's a very special word that Access uses to understand that, hey, you are going to be declaring a variable. Because of that, you cannot use dim as the name of a variable because it's a keyword. And there are several different keywords that are littered throughout Access that you're going to learn you can't use as the name of your variable. In this particular case, I'm going to use the name int age. So here's the name of my variable. So I have dim int age. And then I'm going to say as integer, which is the type of variable. Again, this is the data type. So I'm going to say dim int age as integer. I'm telling Access, okay, I'm allocating some space in the memory. I'm going to name it int age, and the type of value, the type of data that it's going to be is an integer. So now that I've got it assigned, or now that I've got it declared, I have my variable int age declared, I need to assign it a value. Somewhere along the lines, I want to put something in this container. And in this case, I'm going to use for int age is going to be equal to 35. So it's pretty simple. You use the equal sign whenever you want to assign a value to a variable. You just simply use the equal sign. So int age equals 35. Now with some data types, you have to be a little bit more specific. There's some special characters that may need to go around your value. And a good example of that is dates. Now with dates, like in the example of here, I've given a variable of DTE birth date. And I say it's equal to April 1st, 1978, 5:47 and 32 seconds p.m. Now with dates, with the date data type, we'll go over this a little bit later. When you're assigning a value to a date, just so that you're aware, if you do not include the time, then it's automatically assumed to be midnight of that date. And then if you don't give it a date, but you just assign a time, then it's going to assume January 1st of the year 100 AD. And that's just basically the default values that Access is going to assign if you don't automatically give it one. Now for string data types, you're going to actually need to put your string around in quotation marks. So here we've quotation marked Samuel Clemens. So anytime that you're going to be setting a string or assigning a string to a string variable, you need to wrap it in quotation marks. So let's go over some of the main basic data types. I'm not going to go over all of them. I'm just going to give you some basic ones to get you started. The first one we're going to go over is Boolean. And Boolean is just the typical yes or no, true or false, or in the case of Access, it's -1 or 0. I know it's a little wonky. You might think it's 1 or 0, and in fact, in most other relational database systems, 1 is true, 0 is false. But for some strange reason, Access likes -1, or VBA likes -1 to be true and 0 to be false. Most of the time, though, you could just use true or false for a Boolean value, and that's perfectly fine. That's all you need to do is just true or false. Now, a byte, a data type of a byte, is any whole number between 0 and 255. So things like age would be a really good one for a byte range, because obviously you're not going to go less than 0 and you're not going to go above 255. Now notice that you can't assign a negative number to a byte. It must be a whole positive value, and it cannot be greater than 255. If you try to assign anything larger to your variable that's been declared as a byte, you're going to get an error. So just be aware that there are limitations to how much information or the size of the value of what you put in based upon the data type that you're giving it. The next data type is called an integer. And an integer, as it may sound, must be a whole number. It cannot contain decimal values. There will be an automatic rounding up, I believe. I think it's rounding up automatically of your data. So even if you go 0.1, it's going to give it next value up. So make sure that if you're going to be creating an integer data type, that you are going to be assigning it a whole number. And here we can give it a negative value of anything between negative 32,768 to positive 32,767. And that will take up 2 bytes of size in your memory. Notice over here on the right-hand side, I've given you the size of memory that will be allocated for that particular data type. A long integer is going to give you more space, more room for how much data for whatever the value is going to be. But again, it needs to be a whole number. The single is where we start to be able to use an actual decimal value. So a single, you're going to be able to put anything from negative 33,402,823 times 10 to the 38th power. And then anywhere from that to negative 1.401298 times 10 to the negative 45th power. Or you can also do 1.401298 times 10 to the negative 45th power to 3.402823 times 10 to the 38th power. And this is just basically understand you're starting to deal with decimals, and you're going to be able to put in a fairly large range of decimal points in your calculation. If you're trying to calculate pi or whatnot, single's not going to be big enough to calculate pi into, because I think that they have actually figured out where the end of pi is, but I'm not that smart. But I know that a single is not going to be able to contain the whole value of pi. Now, a decimal point, or decimal data type, is like a single. You can contain a decimal, obviously, that's why they call it a decimal. But it's so large that I'm just going to give it really friggin' big, because you can put just about any type of value, any numerical value in here that you want, including decimal values. That is going to automatically assume 14 bytes of data in your memory. And understand, if you're going to make a data type of decimal, and you're only going to give it the value of 1, you're overusing the size, because that 14 bytes will automatically be allocated to that variable. Whether you use all of it or not, that is going to be specifically allocated. So you could very easily, if you just gave decimal to everything, you're going to run out of memory at some point if you really start to develop big, large applications. So being careful about how much or what particular data type you use based upon the values that you put onto it are really important to pay particular attention to. Currency is also another data type that you can use, and notice here that it only goes to the 10,000th. Okay, it's automatically going to round to the nearest 10,000th. For the date data type, understand that you're going to be able to store both dates and times in the date data type. I know that may sound a little funky. You may think, oh, well, I should have a different separate data type for time, but no. Dates and times are stored as one value in a date. And you can have anywhere from January 1st of the year 100 AD at midnight to December 31st, 9,999 again, AD at 23:59:59 p.m. Notice that you are keeping track of seconds, not milliseconds or anything like that. A string value, a string data type, is going to be anywhere from 0 to 2 billion characters. That's right. You can put up to 2 billion characters in a string. And the memory that's going to be allocated for that is 10 plus however many number of characters you have. Okay? Now lastly is a variant, and a variant is very handy because you can put any type of data in a variant. But understand that by doing so, if you're going to put a string ultimately in a variant, then you're going to be occupying 22 bytes plus the number of characters in your string. So that's fairly large. That's going to get very, very big very fast, and you definitely want to avoid variants wherever you can. But the handy thing about variants is when you don't know what data exactly it is that you're going to be putting into it. It's just kind of a general, hey, I don't know what it is going to be that I'm going to put in, so I'm going to declare it as a variant, and that will allow me to use any type of data that I want. Just again, as I must stress, you're going to be using up a lot of memory when you're using variants.